Hello, you guys. I might have a sub or I might be with you, but either way, these announcements are very important. So the fats and nucleic lucid charts are due tomorrow. I will come around to your computer and grade them. If you want to use them on the test, they must be printed and turned in by tomorrow. So I will grade the lucid charts digitally, but if you want to use them on the test, they must be printed. You only need to print them if you want to use them on the test. If you do not, then you do not need to print them. Test is on block day. You can use your lucid chart. The study guide is optional. You do not have to do it, but if you do, it will help you on the test. They're very parallel. There's also a notebook check on block day. What I want to go over right now is page 63. So listen to these 4 slides about carbs, lipids, proteins, and nucleic acids, and then we'll fill out worksheet on page 63. So carbohydrates will always have a 1:2 to 1 ratio with double hydrogen and single amounts of carbon and oxygen. So glucose is C6H12O6. So it successfully has double hydrogen and equal amounts of carbon and oxygen. Usually they'll be in a hexagon or a pentagon structure, like glucose down here is the hexagon, and over here is fructose in a pentagon. Okay, there's 3 types of carbs: monosaccharides, disaccharides, and polysaccharides. Monosaccharides are glucose, fructose, galactose, and they just have a single hexagon structure. Disaccharides have a hexagon to a hexagon or hexagon to a pentagon. In this case, sucrose is glucose to fructose. There are 2 sugars linked together, or 2 geometric shapes like this linked together. Polysaccharides have 3 or more monosaccharides linked together. And it's usually glucose, 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 etc. And for carbohydrates, there's only carbon, hydrogen, and oxygen in the entire molecule. Lipids are long, very long carbon chains, as we can see here, sometimes 50 plus carbons long. Now, once you've identified the long carbon chain as most likely being a lipid, you have to tell if it's saturated or unsaturated. So you look at all the fatty acid chains you have. So in both these pictures, we have 1, 2, 3 fatty acid chains. If there is no double bond in the fatty acid chains, all 3 of them, it's saturated. Granted, there's a double bond there, but it is not in the carbon chain. It is not in the fatty acid chain. Unsaturated fats have 1 or more double bond in any of the 3 fatty acid chains. So 1 would make it monounsaturated, and since these hydrogens are on the same side of the carbon, this is a cis fat. If this hydrogen were down here and they were on opposite sides, it would be a trans fat, very bad for you. But for the most part, these are animal-based and bad for you, plant-based and good for you, except for trans fat. Proteins will always have an NCC, or nitrogen carbon backbone, with the R group off of the middle C. There are 20 different R groups, and every amino acid only differs in what it has in place of this letter R. So here is a polypeptide with 1, 2, 3 amino acids. And off the middle C, you have the R group. So this is a polypeptide. This is an amino acid. Nucleotides will always have a phosphate, that's phosphorus, with oxygen around it, a deoxyribose sugar, so there's a pentagon sugar, and a nitrogen ring. So how do I know this is a nucleotide? Because nitrogen is embedded into the pentagon structure here and into the hexagon structure here. You put many of these together, 6 million in fact, and you get your entire double helix. So here's a bigger picture view: phosphate, sugar, base. There's 4 different versions of what you have right here: G, C, A, and T. Now please go to page 63 in your notebook right here. On this Edpuzzle, I'm going to go through each of these, and if you want to pause this right now and identify it as a carb, identify it as a saturated fat, unsaturated fat, protein, it could be a single amino acid, or it could be a single nucleotide. Identify those, and then I'm going to ask you questions about what is what for the remainder of this Edpuzzle. So please go ahead and answer what molecule is question 1. What is question 2? What molecule is pictured in question 3? What molecule is pictured in question 4? What molecule is pictured for question 5? What molecule is pictured for question 6? What molecule is pictured for question 7? What molecule is pictured for question 8? What molecule is pictured for question 9?